Bright Duty. Every student matters.
Okay, let's move to this exercise here. A metallic sphere of radius 4.2 centimeter is melted and recast into a shape of cylinder of radius 6 centimeter. So there is a metallic sphere and it has got radius 4.2 centimeter. It is melted and recast into a cylinder with radius 6 centimeter, and we need to find its height. Let's say its height is h. Okay. So what is the similarity or what is common in both these shapes? That their volume is same, right? So what is the volume here? Volume of this metallic sphere is 4 by 3 pi radius cubed. So 4.2 cube, and it is equal to volume of this cylinder, which is pi radius square into height. Height I have assumed as h. So only unknown here is h, and I need to find h. So it is only calculation part. So pi can be cancelled, and this can be written as 4 into 4.2 into 4.2 into 4.2 divided by 3, and this 6 square can be written here. So it is equal to h, right? So now 6 sevens are 42, so this is 0.7, and this is also 0.7 here, and 3 1.4. okay. So h is equal to 0.7 into 0.7 is 0.49, 14 into 4 is 56, so it is 5.6. so this height will be in centimeter. So you just need to multiply 56 with 49, and then we will put a decimal at after 3 places. Okay. Two 744, and here the decimal will be there, centimeter. So this is the height of this cylinder, right? So let's look at the next one. This time metallic spheres of radii 6 centimeter, 8 centimeter and 10 centimeter are melted to form a single solid sphere, and we need to find the radius of the resulting sphere. This time also the volume of these 3 spheres collectively will be equal to the volume of the new sphere. So what is the volume of 3 spheres with radii 6 centimeter, 8 centimeter and 10 centimeter? It is equal to volume of the resulting sphere, right? We are melting these 3 spheres to make a single sphere of, let us say, radius r. Radius, let us say, is r. So these volumes will remain same. So volume of the resulting sphere is 4 by 3 pi radius cubed, and volume of these 3 spheres collectively is 4 by 3 pi 6 cubed plus 4 by 3 pi 8 cubed, 4 by 3 pi 10 cubed, right? And we need to equate these, and we will find value of r. So you can see I can take 4 by 3 pi common. So 6 cube plus 8 cube plus 10 cube is equal to 4 by 3 pi r cube. So 4 by 3 and pi, 4 by 3 and pi can be cancelled. So r cube is equal to 6 cube plus 8 cube plus 10 cubed, right? So what you can do is, if you don't know what is 8 cube or what is 6 cube, what you can do is you can take 2 cube out. So if I take 2 cube out, I'll have 3 cube plus 4 cube plus 5 cube inside. Now I think you know 5 cubed is 125, 4 cubed is 64, 3 cubed is 27, right? So you can write it as 2 cube. This is 27 plus 64 plus 125, right? So 2 cubed into, if you add these, what will you get? 120 plus 60 is 180, 189, 196, 216, right? And you know what is 216? It is 6 cubed. Okay, 6 cube is equal to 216. So effectively I have got r cube equal to 2 cube into 6 cube. So what is r? R is equal to 2 into 6, which is 12. So the radius of the resulting sphere is 12 centimeter. So this is your answer, right? So what I have done is I have taken 3 smaller spheres, I have melted them and made it into a bigger sphere. So the volumes of these 3 spheres when added will be equal to the volume of the resulting sphere. So I have equated these volumes and found the value of r. After that it was just the calculation part. Once you know this equation, after this it is only the calculation, right? Okay, there is a 20-meter deep well with diameter 7 meter and the earth from digging is evenly spread out to form a platform 22 meter by 14 meter. Find the height of the platform. So well is in the cylindrical shape, right? And this well is 20 meter deep and its diameter is 7 meter, so its radius is 7 by 2 meter, right? So its radius is 7 by 2 meter and it is dug. So the earth is taken out from it and a platform, it is evenly spread out to form a platform, and 2 dimensions are given, 22 meter by 14 meter. We need to find the height. So it is cuboidal in shape, right? We are given these dimensions, 22 meter by 14 meter, and we need to find this dimension. Here let us say it is h. Okay. So what is being done is, this is a well of cylindrical shape. So it is dug, so the earth is taken out from it, it is spread to form this platform. This is cuboidal in shape. Okay. So the volume of earth in cylindrical well, or if it is made, if the earth is used to make a platform of cuboidal shape, what will remain constant in this process? The volume of the earth that is taken out, right? So volume here is equal to pi radius square into height, right? It is in meter cubes. And volume of earth used to make cuboidal platform is equal to length into breadth into height, which is h. And these two volumes have to be equal because it is the same thing that is being taken out and it is the same thing that is being used there to form the platform. So there will be no change in volume. So this is equal to this volume. So I am equating these two. So pi 7 by 2 into 7 by 2 into 20 is equal to this, which is 22 into 14 into h. Okay. So if I write pi as 22 by 7, 7 by 2, 7 by 2 into 20, it is equal to 22 into 14 into h. So this 22 can be cancelled, 7 here can be cancelled, and this 7 will give 2 here. So 2 into 2 is 4, 4 into 5 is 20, right? So h is equal to 5 by 2 meter, right? Because the dimensions are in meters. So height of the platform that will be made is 5 by 2 or 2.5 meter, right? Okay. Okay, there is another well which has got diameter 3 meter and is dug 14 meter deep. So there is a well and its diameter is 3 meter, so its radius is 3 by 2 meter and it is dug 14 meter deep. So this may not be the entire well may be beyond it, right? You can keep on digging and it will you will go deeper and deeper, but we are digging only up to 14 meters. Earth taken out is being spread evenly around it in the shape of a circular ring. So the earth is being used to make a platform this time, which is in the form of a circular ring around it, right? So this kind of platform will be made. Okay. So its width is 4 meter. To form an embankment, find the height of the embankment. So the circular ring has a width of 4 meter. So this width here up to this is 4 meter, right? So now the earth that is being taken out from this well is being spread around it to form a circular ring, right? So the volume of the earth taken out and the volume of this shape here is same. So volume of earth taken out is equal to pi radius squared into h height, which is 14, right? It is in meter cubes. And volume of the embankment, okay, let us say it is embankment. So volume of embankment, let us assume its height as h, okay, it is equal to how much? This is a hollow cylinder, right? Let us say this is a hollow cylinder. So what is the volume of the embankment? It is pi outer radius. So what I am trying to say is, let us say this is a hollow cylinder of this shape, right? Okay, so I need to calculate this volume here. Let us say it is metallic, so I need to calculate the volume of the metal used here. What will be this volume? Volume of the outer cylinder minus volume of the inner cylinder, right? So volume of the outer shape is pi. What is outer radius? It is 3 by 2 plus 4 meter, which is the width of this embankment. So 3 by 2 plus 4 is how much? 3 by 2 is 1.5 plus 4, so it makes it 5.5. So radius squared into height we need to calculate minus pi inner radius, which is 3 by 2 squared into height that we need to calculate. So this volume is equal to this volume, okay? So let me equate these volumes. Pi 3 by 2 square into 14 is equal to pi 5.5 square into h minus pi 3 by 2 square into h, okay? So you can see pi h can be taken as common from here for the sake of simplifying the calculations, and 5.5 I always prefer writing it as 11 by 2, right? So 11 by 2 square minus 3 by 2 square will remain inside if I take pi h common outside. So pi 3 by 2 square into 14, pi can be cancelled here, right? Now this is a square minus b square type, so h into 11 by 2 plus 3 by 2 into 11 by 2 minus 3 by 2. And here on the left hand side I have got 3 by 2 square into 14. So this here can be written as 14 by 2. So h into 14 by 2, and here this can be written as 8 by 2, and it is equal to 3 by 2 square into 14. So 14 can also be cancelled. Okay, so it is h, and this can be written as 3 by 2 into 3 by 2. This 2 into 2 can be taken here, and this 8 here. So 2 into 2 is also cancelled. So h is equal to 9 by 8 meter. Okay, so this is your answer for the height of the embankment, right? Okay, now I have got a container shaped like a right circular cylinder having diameter 12 centimeter and height 15 centimeter. So there is a right circular cylinder with dimensions. Diameter is 12 centimeter. So what is the radius? 6 centimeter. And what is the height? 15 centimeter. It is full of ice cream, and the ice cream is to be filled into cones of height 12 centimeter and diameter 6 centimeter having a hemispherical shape on the top. So these kind of cones have to be filled. Okay, so there is a conical shape in the bottom and hemispherical top is there. And what is the radius? Height of this conical part is 12 centimeter and diameter is 6 centimeter. So the radius is 3 centimeter. Right? So we need to find number of such cones. Okay, let us say x number of cones can be filled. So how to think about this question? If I fill one cone, okay, and I am filling x number of cones, so whatever ice cream I fill in these cones is coming out of this cylindrical vessel or a cylindrical container, right? So the volume of ice cream in this container is equal to volume of ice cream in these cones, x number of cones, right? So if I calculate volume in one cone and multiply it with x, this volume will be equal to the volume of this cylindrical container, right? So volume of cylindrical container is equal to x into volume of one ice cream cone, right? And you need to appreciate this cone is formed of two parts. One is conical and another is hemispherical. So volume of one ice cream cone is consisting of two parts. Volume of this conical portion, which is 1 by 3 pi radius squared into height, which is 12, plus volume of this hemispherical part, which is 2 by 3 pi radius cubed, so 3 cubed. So this is my right hand side. Volume of cylindrical container will be put on left hand side, which is pi radius squared into height, right? Once you know this equation, you just need to find x here. So the calculation part is left, and to simplify the calculation, I'll take certain things as common. Okay, so I can 3, there is 3 square, so I can write it as 3 cube is there, so this will become 3 square here. So x is outside, pi can be taken outside, 3 square in fact can be taken outside, because 3 square is 9. Here I have got 12 into 3, which is 36. So if I take 9 common, this is 12 into 3, 36, so 4 will be inside, plus from here I have taken 9 pi as common, so 2 will remain inside. Okay, So this is equal to x into pi into, this is 6 into 9, which is 54. And on the left hand side I have got pi into 6 into 6 into 15. So pi is cancelled out. 6 9s are 54, 3 2s are 6, 3 3s are 9, and 3 5s are 15. So x is equal to 10. So 10 such cones can be filled using the ice cream in this cylindrical container. Okay, so this is how you will deal this question. All right, how many silver coins? So the next question is, how many silver coins 1.51. So the question here is, how many silver coins 1.75 centimeter in diameter and of thickness 2 mm must be melted to form a cuboid of these dimensions, right? So there are silver coins, right? This is the shape of a coin, right? So if you notice, a coin is a cylindrical shape with thickness 2 mm and this is the diameter. So the radius here will be 1.75 by 2 centimeter. So, and these silver coins are to be melted to form a cuboid. And dimensions of the cuboid are also given, which are 5.5 centimeter, 10 centimeter and 3.5 centimeter. These dimensions are in centimeter, right? And thickness is given in millimeters, which we will convert into centimeters. So how many silver coins? Let us say x silver coins are there which are to be melted. So if we melt x silver coins to make this cuboid here, so the volume of these x silver coins will be equal to volume of this cuboid. So I just need to find volume of one silver coin and multiply it with x, and then I'll equate this volume with the volume of this cuboid, right? So x into, this is cylindrical shape, pi radius square into height thickness, right, which is 2 mm. So I'll write it into centimeters as 2 by 10, and it is equal to volume of this cuboid 5.5 into 10 into 3.5. Okay. So we can find x by 5.5 into 10 into 3.5 divide, and this 10 is also getting multiplied here. This 2 square will also come in the numerator. So in the denominator I'll have pi 1.75 square and this 2, right? So this will give us 2 here. Pi can be written as 22 by 7. So this is 5.5 into 10 into 3.5 into 10 into 2 divided by, this is 22 by 7. So 7 will come in the numerator, 1.75 into 1.75. Okay. What is 1.75? It is half of 3.5, which is half of 7. So 1.75 is 7 by 4. Okay. So what you can do is, rather than writing 1.75 into 1.75, you can write 7 into 7 by 4 into 4, right? Even these 4s can be taken in the numerator. Now the calculation has become a little simpler. Okay. This 22, 11 2s are 22, 11 5s are 55. So 0.5 will come here. This 2 can be cancelled, 7 can be cancelled. 3.5 into 2 is 7, 2 into 2 is 4. I hope this is not getting messy. I hope you understand my intention here. I want to simplify the calculations for you. Otherwise, you are supposed to do these calculations yourself. So I am just suggesting some of the ways that can be used to do faster calculations. 0.5 into 10 is 5, 5 into 10 is 50, 50 into 2 is 100, 100 into 4 is 400. Okay. So you please take care that nothing is left here in the calculation. 0.5 into 10 is 5, 5 into 10 is 50, 50 into 2 is 100, 100 into 4 is 400. So 400 coins have to be melted to form a cuboid of these dimensions, right? Okay, there is a cylindrical bucket and the dimensions are: height is given as 32 centimeter, radius of the base is 18 centimeter. It is filled with sand. The bucket is emptied on the ground and a conical heap of sand is formed. So a conical heap of sand is formed, right, by emptying this bucket. If the height of the conical heap is 24, so this height is 24 centimeter, right. We need to find this radius. Let us denote this by r. We need to find r, and slant height, let's denote it by L. If we find r, we can find slant height just by using Pythagoras theorem. So that will be easy. So let's first of all focus on finding radius of the heap. So we will again use that concept that the volume of the sand will remain constant whether it is in cylindrical shape or in a conical heap shape. So volume here is pi radius square, 18 into 18 is radius square, r square, right, into height h, which is 32. Okay. So volume of the sand in this cylindrical bucket is pi radius square, which is 18 into 18 into height, which is 32, and it should be equal to volume of the sand of this conical heap, which is 1 by 3 pi radius squared, which is r square, into height, which is 24, right. So using this equation we can find value of r. So pi can be cancelled. So 6 4s are 24, 6 3s are 18, 4 8s are 32, right. So r square is equal to 3 into 18 into 8 into this 3, right. So this is what? 3 into 3 is 3 square, and this is 6 into 3 into 8. So you can write it as 3 into 2. So 3 square into, this can be written as 3 into 2 into 3 into 8. So 3 into 3 is again 3 square. So if I need to find r, I will have 3 from here, and these two 3's will give me 1 3 here. 8 into 2 is 16, so it will give me 4 here. So this is 36 centimeter. So the radius of this conical heap is 36 centimeter, right. Now I need to find the slant height. So L is equal to radius square plus this height square, which is 24 square, square root, right. So radius square is 36 square plus 24 square, and then there is a square root. So to calculate this, I will try to take what is common in 24 and 36, right. 12 is common in both. So 12 square, if I take common, here I will have 3 square and here I will have 2 square. I can write it like this. So 12 can be taken out of this radical sign, or this square root sign, right, and what will be left inside is 3 square is 9, 2 square is 4. So 12 square root 13 centimeter is the slant height of this conical heap. Okay. Okay, there is a canal and there is water 6 meter wide and 1.5 meter deep is the canal. This water is flowing with the speed 10 km per hour. How much area will be irrigated in 30 minutes if 8 centimeter of standing water is needed? So to irrigate this field or this area, we need 8 centimeter of standing water. So we need to find the area. We are already given the height of this water. We need to find length into breadth. I hope you understand. So this canal is 6 meter wide and 1.5 meter deep, and water is flowing in with the speed of 10 km per hour. So speed of water is equal to 10 km per hour, and we need to find area irrigated in 30 minutes. So length of water column in 30 minutes is equal to, in 1 hour it is 10 km, right? So in 30 minutes, half the time it will be 5 kilometers. So if I want to convert it into meters, it will be 5000 meters. Okay. So I have got the length of the water column, width is already given, depth is given. So the volume that flows out in 30 minutes is equal to this length into this width into the depth 1.5. So this volume of water is flown out in 30 minutes, and it is to be used to irrigate a land which needs 8 centimeter of standing water at least, and we need to find area of that land. So area of the irrigated land is equal to length into breadth, length of that land and breadth of that land, right? So the volume of water used will be length into breadth into 8 centimeter of standing water that is needed. So 8 centimeter here, I will convert it into meters. So let me divide it by 100. So in meter cubes you need this much volume, and it is the same volume that is flown out of that canal, right? So I need to equate this with this. So 5000 into 6 into 1.5 is equal to L into B, or we can say area, into 8 by 100. So L into B is equal to 5000 into 100 into 6 into 1.5 divided by 8. Okay. Right. So this is area equal to 5000 into 75 into 1.5. into 5000 is 7500 into 75. This area is in meter squares, right? So because we have converted every unit in meter, so this area will be in meter square. Further you can multiply 75 with 75. So this will give you 562,500 meter square. This is the area that will be irrigated, right? Okay. A farmer connects a pipe of internal diameter 20 centimeter from a canal into a cylindrical tank in her field, which is 10 meter in diameter and 2 meter deep. If water flows through pipe at a rate of 3 km per hour, in how much time will the tank be filled? So it depends on what is the volume of this tank and what is the volume that is being flowing out of this cylindrical from this canal, right? So there is a canal and a pipe is attached to this cylindrical tank from that canal, right? There is a canal, right? And this pipe has internal diameter of 20 centimeters. So radius of pipe is equal to 10 centimeter, right? And this cylindrical tank's dimensions are 10 meter is diameter, so 5 meter is the radius, 2 meter depth, right? Okay, so volume of the tank to be filled is equal to pi radius squared into height, meter cubes. Okay, so I need to find the how much time will this volume of water will take to flow out of this canal using this pipe here, right? In 1 hour, the rate of flow is 3 km per hour. So length of water column in 1 hour is equal to 3 km. Okay, and you notice that this radius is 10 centimeter. So this pipe is also cylindrical. So the volume flown out in 1 hour is equal to pi radius square. Radius is 10 centimeter. So 10 into 10, this is radius squared, into length of the water column. Okay. So length of water column in 1 hour is 3 km. Now this dimension is in centimeter, this is in kilometer. So let's convert these into meters. So 3 km can be written as 3000 meters and 10 centimeter can be written as 10 by 100 meters, 10 by 100 meters. So this much volume is flown out in 1 hour, it is in meter cubes. So this much volume will flow out in how many hours? This is what we need to calculate. So this is 10, this is 10, 10 into 10 is 100, so this is 30, 30 pi meter cube, and this is 5 into 5, 25 into 2, 50 pi meter cube. So we can say 30 pi meter cube is flown in 1 hour, right? So you can calculate how much time it will take to fill a volume of 50 pi meter cubes. 1 meter cube will be flown out in 1 by 30 pi hour, right? And 50 pi meter cube will be flown out in 50 pi divided by 30 pi hours. So pi can be cancelled, this will give you 5 by 3 here. 5 by 3 hours can be converted into minutes by multiplying it with 60. So 320, we can write it as 100 minutes also, right? So in 100 minutes this tank will be filled. Okay, rather than writing 100 minutes, you can also write 1 hour 40 minutes also, 1 hour 40 minutes. So it depends on the format of the answer that you need to write it into. Okay, so this was about this question. I hope this exercise is clear to you. Thank you.